As a solar system ambassador, our program is meant to foster outreach and education. All opinions and commentary are my responsibility. So if I mess up, blame me, not NASA. And as you can see from the picture here, the cost of going to Mars has increased slightly since the early part of the 20th century. Inflation is terrible. This is what we look like from the surface of Mars. I guess it was a Martian Astronomy Club that took this. Mars has fascinated us for decades. We have, of course, H.G. Wells and War of the Worlds, which became a hit motion picture back in, I think it was like 1952. On the right-hand side, we have Orson Welles and his infamous radio broadcast that scared the heck of out of a lot of people. And I actually used a recording of that broadcast in another of my presentations. And you can see why people back then would get scared, especially if they didn't listen in from the beginning when he gave his warning that this is fake. So we're going to start with history. The Grand Tack model. What was the solar system like before it became the solar system? And I say planets start your engines because I equate it to a demolition derby. Everything was smashing into everything else. Planets were not formed. Jupiter, being the big bully of the solar system, moved inward towards the rocky planets, that's us, and plowed icy material along its path. It then ran into the asteroid belt and started flinging the asteroids around the solar system. Some were ejected out, some went to other regions. And material that Mars could have used to become bigger or accrete was pushed out of its reach. And that's a big reason why Mars is much smaller than Earth. The Earth was saved, however, from a fate worse than death by Jupiter because Saturn moved in and told Jupiter, hey, back it up a little. So Jupiter backed away, and we've got the solar system as it appears today. 4.5 billion years ago, both Mars and Earth formed, but Mars was more Earth-like than Earth. It was warmer and wetter, and you can see from this, from these pictures, that 4 billion years ago, Mars had oceans, and we go through the eras, and we wind up with now where it's a dry, dusty place. Giovanni Schiaparelli, one of my paisans, in 1877, we drew this map of the canales. And then Percival Lowell comes along, and in 1895, he publishes these drawings. And between this and Schiaparelli's drawings, people thought, oh, there are canals on Mars, so there's water on Mars, and if there's water on Mars, there's life on Mars. So ancient Mars had surface liquid water, and this was about 3.6 billion years ago. There was huge impact about 4 billion years ago that flattened the North Pole. We can see it on this globe. Let's see if I can do this. So if I started out here, if we all started out here and wanted to walk south, we'd actually be going uphill first because of that impact. And we have to get through a lot of ice as well. So some facts about the red planet. The average distance is 140 million miles. The closest it comes is 34 million miles, and the maximum distance is about 249 million. A couple of things. First, Earth and Mars, of course, go around the sun, but nothing goes in a perfect circle. It's all the orbits are elliptical. Um, and the distance between the two planets constantly changes, which can complicate communications. When Mars and the Earth are at the opposite sides of the sun, and the distance being 249 miles, it takes 21 minutes for an electromagnetic wave or a signal to go from Mars to Earth. The closest, when the planets are 34 million miles apart, the time goes down to 4.3 minutes. What this means is that if you need 911, it ain't available. It's going to take either 21 minutes or 4.3 minutes. And I've got a slide in a little while with what's happened recently with the International Space Station, which will give you an idea of why that could pose an issue. There is a possible way to overcome that, and this is a new field, quantum mechanics. It's the field, the study of the very small subatomic particles. It could lead to instantaneous communication, and it has been proven so that if you have one particle here on one side of the universe and another particle here, regardless of the distance, for some reason, they can communicate instantly. So what happens here will happen there. So if we can use this for interstellar travel or interplanetary travel, that will solve many problems. Einstein didn't believe in it. He called it spooky action at a distance. Of course, we know that Earth's year is 365 days, and Mars is 687 Earth days, or 669 sols, which are Martian days. Mars has seasons just like we do. The reason why we have seasons is because, in addition to go around the sun, we're tilted on an angle of 23.5 degrees. Mars is tilted at 25 degrees. So we have, when it's summer in the southern part of Mars, it's winter in northern. We have a southern fall along with a northern spring, a southern winter, northern winter, southern spring with northern spring. So very similar to Earth. And these are the lengths of the seasons. Spring on Earth is 93 days. Mars is 194, and I'll jump down to winter since we're in the middle of winter here. It's 89 days, and it's 154 days on Mars. So what makes Mars the red planet? There are some new ideas about it. We already knew that on Mars, over billions of years, iron oxide has been ground into dust, and then it's carried across the entire planet by the Martian winds. And they can get to be so powerful that the entire planet can be covered in this red dust. But the iron oxides, they're not all the same, and there's been a debate about the nature of the dust on Mars. And after extensive testing, we found that the best match is a combination of basaltic, which is a dark, hard volcanic rock, and a water-rich iron oxide called ferrohydrite. And it's intriguing because ferrohydrite forms rapidly in the presence of cool water, meaning it must have originated when liquid water was still on the surface of Mars. Even after billions of years of being ground into dust and scattered by Martian winds, ferrohydrite has retained that watery signature. So this gives us a clue. And the implication is that because ferrohydrite could could only have formed when water was still present on the surface, Mars rusted earlier than we thought. The atmosphere of Mars, of course, the major part is 95% carbon dioxide, and we have nitrogen, argon, and a mere 0.174% of oxygen. Whereas on Earth, we've got 78% nitrogen and 21% oxygen. So how did Mars lose its atmosphere? Well, the big reason is, of course, Mars is so small. And as we saw a few slides ago, Mars is so small because it couldn't get enough material to become bigger. The atmosphere is 100 times thinner than Earth's. The atmospheric pressure is 100 times less. And the molten core cooled about 4.2 billion years ago. The molten core is what spins in the Earth's center and gives us our electromagnetic field and protects us from the solar wind, the charged particles coming off the sun and streaming out into the solar system. So because the cooling of Mars's core, it made Mars susceptible to the solar wind, and it stripped away the atmosphere. It's still leaking out into the space. And the leading theory is that Mars' light gravity, coupled with its lack of global magnetic field, left the atmosphere vulnerable to that solar wind, and water still exists on Mars. And we'll see how much water is there. But the atmosphere is too thin for it to last on the surface. So it had to go underground. And so the question became, well, if the water went underground and life needs water, did life go with the water underground? Mars weather on an average day, it's about minus 81 degrees Fahrenheit. Near the poles in winter, there's a low temperature of minus 195 degrees. And near the equator in summer, it's a balmy 70 degrees. The highest temperature that we found is 86 degrees. We'll break out as bathing suits. Can you imagine Martians walking around in bathing suits? Dust storms. Mars has incredible dust storms. As I mentioned, it could cover the entire planet. And that's how we lost one of our rovers, Opportunity. The solar panels became covered with the Martian dust and couldn't get the energy from the sun. And then it eventually died. And several times a year, large dust storms bloom on Mars, and they cover thousands of square miles. And so this is a picture of a part of Mars today. Not very hospitable. This is the Valles Marineris hemisphere of Mars projected. Well, it's a view similar to that what you would see from a spacecraft. It was taken 2,500 kilometers up from the surface of the planet, and it was the Viking orbiter that took 102 pictures of Mars to create this one. So you can see it looks like a giant scar on the planet. It has two moons, Phobos and Deimos. So the question was, how did Mars get its moon? And here is a video. We have a similar theory that's a prevailing theory about how we got our moon. It was caused by a giant impact of a Mars-sized planet or body that they gave the name of Theia to. And Theia gave a glancing blow to the young Earth, which threw off material and created a ring similar to Saturn's rings. And eventually that coalesced into our moon. And
For a little savings, Specialist Miller buys in bulk. For a lot of savings, she
it's an ad. Do you want to get out of it? Yeah, I want to get out of that. Go to the next slide. Um, Thank you. This is a picture of an impact crater that was taken by the ExoMars Trace Gas Orbiter. And this was an ancient asteroid impact. And has a diameter of roughly 2,050 miles, or twice the size of our Sahara Desert. And there are ice-related features on and below the surface of the crater. And we'll see a couple more craters that have ice in them. This is a great picture of Mars sunrise taken on November 4th, 2023. And this is another picture taken by our rover InSight. And so we're going to go from sunrise to sunset. Interesting choice of music from Mr. McLeod. Okay. Sorry, how do I do this again?
oh, it's just here.
Oh, okay. Got it. There we go. I'll remember next time. So, a mantra in trying to find life on Mars, or whether it ever existed, is to follow the water. And there's lots of evidence for it. You know, the reason why water is so important is because we were talking earlier about baking a cake. Well, with water, without water, you've got all the ingredients for the cake. The flour, the sugar. I'm not a baker, so I can't tell you what else is in there. And What happens when you put it into a bowl? You have glop. What do you need? Some sort of liquid, like water or milk. And when you add that, then you can start baking. So that's what happens with water in the solar system and in the universe. You can start cooking. Asteroids bombarded Mars nearly 4.5 billion years ago, and they may have delivered enough water to create a global ocean that's 1,000 feet deep. And this is an artist's concept of what it could have looked like. Water ice was discovered by the Mars Express, and it's salty water. Salty water is important for life. 3.5 to 4.5 billion years ago, these may have been rivers. I gotta take my glasses off. These etchings in the surface may have been rivers. This is an ancient beach on Mars discovered by China's Mars rover, and it strengthens the case for habitability. But today, as we know, it's a cold desert of rock and dust. But who knows about 4 billion years ago, we are certain that it had water. So it had rivers, lakes, and even oceans with sandy beaches. And this is a map of the Aeolus dorsal region on Mars that shows evidence of an ancient ocean shoreline. And this is just another artist's concept of Mars with oceans more than 3 billion years ago when it was warm, wet, and had an atmosphere that could have supported life. This is interesting. Curiosity took these two pictures, and it's in the clay sulfate transition region. And you can see that there are hexagonal patterns here. And they suggest that there are mud cracks formed when many wet-dry cycles occurred over years. Blueberries on Mars. These are iron oxide rocks that become these blueberries when they're washed over by water. In fact, we have them here on Earth. So we know this is true. And this is evidence of an ancient lake at the bottom of Jezero crater. And Jezero is where we hope to find traces of life. Perseverance landed in there. It was part of the Mars 2020 program. More recently, September of 2024, there is water on Mars. There's a massive deposit of water ice that was discovered beneath the Mars equator. And if melted, it could cover the planet in an ocean 5 to 9 feet deep. And this was the result of 20 years of exploration. And these deposits here are actually water ice. Curiosity took this picture of the Geddes Vallis Channel on March 31st, 2024. This is a region that was likely formed by large floods of water and debris. Scientists found that the mid-crust of Mars, which is about 6 to 12 miles down, may be riddled with cracks and pores filled with water. And they could hold enough water to cover all of Mars that's up to 1.2 miles deep. And this reservoir of water could have percolated down through the nooks and crannies billions of years ago, only stopping at huge depths because the pressure would fill up the cracks. On Earth, these water-filled rocks can host microbes, even while buried deep in the crust. And this image is from the InSight lander. This is a picture of the red velvet crater. And we can see the ice that's at the bottom of that crater and the coral of the crater. It has a 50-mile wide sheet of solid ice that is 1 mile thick. And scientists think that these bands of rocks were formed by a very fast, deep river. On January 14th of this year, we found that ancient lakes grew shields of ice to stay warm as Mars froze over. And they potentially solved the paradox of how liquid water seems to have persisted on Mars even when the climate grew too cold. So the ice protected the water that was on the planet. It could have sheltered lakes on ancient Mars and kept surface water liquid even when the climate became freezing. So with all that water, could this have been a Martian that landed on Earth? This was December of 1984, and it was discovered, I'm sorry, I forget where, but it was discovered here on Earth, probably in Antarctica. Bill Clinton, who was the president at the time, saw this picture, went out and gave a press conference and said, "We found life on Mars." And he was a bit premature. Some people say it is evidence of life, and some people say it's not. The debate still goes on. So, exploring Mars, there are 4 goals. Determine if life ever arose on Mars. What's the climate like? What's the geology like? And then we want to prepare for human exploration of Mars. And of course, our strategy, as I mentioned before, is to follow the water. This is how we landed Perseverance on Mars. It's a great video.
Now supposed to subsonic speeds and the show has been separated. But meters off the surface.
Bingo Delta.
That has confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
In the bottom of the parachute were the words, "Dare mighty things." So Perseverance, there were 4 main science objectives. One is geology, and that's around the landing site in Jezero crater. Astrobiology, determining whether there's an area of interest that was suitable for life. Sample caching, taking samples of Mars, putting them in the tubes, and somehow getting them back to Earth, which I'll explain in a couple of minutes. And then to prepare for human exploration. So why did we choose Jezero? Well, scientists believe that the area was once flooded with water, and it was once home to an ancient river delta. Over 3.5 billion years ago, river channels spilled over the crater wall and created a lake. And they've seen evidence that water carried clay minerals from the surrounding area into that crater, and microbial life could have lived in Jezero during one or more of these wet times. If so, signs of their remains may be found in the lakebed or shoreline sediments. And this is a video of Perseverance exploring that delta. It's a little bit long.
This beautiful mosaic is the most detailed image ever taken on the surface of Mars. It captures some of the sedimentary rocks that scientists came to the red planet to study. Only the very edges of the rover are visible in this mosaic. NASA's Perseverance Mars rover is now exploring a really important part of Jezero crater. Around 3.5 billion years ago, a river flowed into Lake Jezero, depositing mud and sand on the crater floor, forming an ancient delta. What you see are some of the hills and cliffs at the edge of that delta. Here you can see some of Perseverance's wheel tracks, showing where we came from on the crater floor, where we spent the first year of our mission. Take a look at the darker gray layered rocks that make up the roughly 32-foot-tall cliff in front of the rover. You can see very clear horizontal layers in these rocks. And you'll also notice pieces of the cliff have broken off and tumbled downhill. One of the more interesting ones is the 3-foot-tall boulder called Betty's Rock, which Perseverance was able to get a closer look at. These rocks have been sitting on the surface of Mars for billions of years. And over that time, wind erosion has shaped the surface into pretty interesting forms, like this balanced rock.
Like that one.
Immediately surrounding the rover is an area called Hogwallow Flats, previously known as the Bacon Strip, based on its appearance in orbital images. Take a look at the bright rocks the rover is sitting on. We think these are some of the finest grained sedimentary rocks deposited in the delta. Fine-grained rocks are important because they're typically really good places to look for signs of ancient life. We plan to do up to 5 abrasions on the rocks in this area. That's where we use our drill to expose a fresh surface, which allows us to analyze the chemistry and mineralogy. But Mars threw us some curveballs, and these softer rocks didn't always cooperate. Here you can see the result of one of our abrasion attempts. The rock crumbled during the abrasion, preventing us from analyzing the spot. We had 2 unlucky abrasion attempts in this area before achieving success at the Skinner Ridge outcrop. Here we collected our first 2 rock core samples from the delta, and since then, we've collected 2 more. Perseverance drove to the delta because it is a very promising place to look for signs of ancient life. We hope to learn more when a future mission brings these samples back to Earth. So far, we're excited by what we've collected.
One of the last images taken by our InSight lander. It was taken on December 11th, 2022, the 1436th Martian day of the mission. And you can see the seismometer. 2 Mars quakes occurred in August and September of 2021. And we have another video of the planet. Dust devils. which kind of look like tornadoes here on Earth. Perseverance captured the sound of dust devils. Big sound. Video of the Perseverance rover, a panoramic view that it took. Along with Perseverance, the rover, we sent the helicopter. And the helicopter essentially acted as a scout team. It would fly out ahead of Perseverance and then radio back to Perseverance to say, hey, I found an interesting spot. Come over here. So it was solar powered and it flew ahead of the rover, as I mentioned, almost every day, checking out points of interest for the rover to go to. And it helped the engineers back on Earth plan the driving routes. And it weighed 1 kilogram. The blades were 1.1 meters across on the tip of one blade to the other. And it looks like a medium-sized cubic tissue box. This is actual video taken from Mars of the helicopter taking off. Does everyone see it? This is the first time a winged craft has been on another planet. Well, that we know of. And here it is on April 22nd, 2023, during its 51st.
On Vintage, turn extra clothes into cash. Sell with 0 fees. Don't wear it, sell it.
A moment to listen.
How do I arm my body?
Through movement that grounds me.
Let's get this. Oh, there we go. It spotted its big brother, Rover. So unfortunately, after 72 flights, Ingenuity ran into a problem. It had a hard landing, breaking the blades. There was poor visual navigation that led to an erratic attitude and altitude tracking. It rolled, the blade tips failed on landing, and the rotor imbalance leads to blade ejection and burnout. So it died. But we thought it was going to last maybe 5 flights on Mars, and it lasted 72. This is a picture of the Valles Marineris. This is the largest canyon in our solar system. Olympus Mons, the largest volcano in the solar system, 13.6 miles high. And it might have once been a volcanic island surrounded by an ocean that was nearly 4 miles deep. And it's as big as the state of Arizona. ExoMars, a mission in 2016, it was supposed to be a second mission in 2020, but it was sidetracked a bit due to delays and then the Russians attacking Ukraine. But the mission consisted of an orbiter and a lander called Schiaparelli, and they did travel together and then separate as they reached Mars. And we wanted to search for evidence of methane and other trace atmospheric gases, because methane is an indicator of life. The mission was launched on March 14th, 2016, and it flew to Mars in 7 months. And 3 days before reaching the atmosphere of Mars, the Schiaparelli was ejected from the orbiter towards the red planet, coasting towards its destination, opened the parachute, and landed on Mars. So collecting the samples of Martian soil, these are the collection tubes dropped off by Perseverance. And this is the Jezero crater, which is the sample depot for all these sample tubes. This is a look inside one of the tubes, and it could contain the best evidence of Martian life. It has hydrated silica, and here on Earth, it shows the highest potential to preserve signs of ancient life. So, this is a video about the rock samples. So, you may ask, how are we going to get the samples back to Earth? And I'm going to respond with, that's a good question. um, NASA originally adopted a dual lander architecture, with the second lander carrying a European-provided fetch rover. The igneous rocks, which is solidified lava, samples so far show signs of mineral alteration by water and organic compounds, and they support the theory that Jezero crater could have been habitable billions of years ago. So this is what was canceled. We have Perseverance with the sample tubes, dropping them off in a carrier, which would then put it on a rocket, which would go up to a satellite, which would then come back to Earth. It ain't gonna happen. It was canceled because of cost. And people were outraged, and rightly so. According to Victoria Hamilton, we were on the cusp of finally determining whether there was life on ancient Mars, and the logic for where to go and which samples to collect has been rigorously and widely debated. She told space.com, and space.com, by the way, if you're looking for great news about what's going on, go to space.com. She said there are incredibly tantalizing samples in the rover's cache that could revolutionize our understanding of life in our solar system. It will also provide invaluable information about the surface environment of Mars for the Moon to Mars program that could greatly reduce risk to human explorers and save billions of taxpayer dollars. So, getting them back to Earth. Well, the rover is still surveying the River Delta, and we're considering two possible Mars sample return strategies. Originally, the process I showed you had an original cost estimate of $8 billion to $11 billion. And it would require multiple launches to Mars in order to place the Mars ascent vehicle on the red planet's surface. There are two options that we're looking at. The first is we would employ a rocket-powered sky crane, the system that landed Perseverance on Mars in August 2012 and February 2021. The second would rely on private industry to provide the landing system. So going with the sky crane would result in a cost of only $6.6 billion to $7.7 billion. The commercial option would be a bit cheaper, $5.8 billion to $7.1. So some recent developments, additional ones, those dust devils that I showed you before, they were found to contain lightning. Perseverance's microphone detected electrical discharges, like mini lightning, within those dust devils. And that affects the atmospheric chemistry and habitability studies. Subsurface secrets are enhanced radar from the Mars reconnaissance orbiter suggesting a large underground feature at the South Pole is rock and dust, not what they previously thought, and ancient magma. Samples from the Margin unit show olivine, indicating magma activity beneath ancient Mars. So obviously there were volcanoes on Mars. For potential signs of ancient life, we have those Jezero crater rocks. There were sedimentary rocks that were found with leopard spots and poppy seeds that contain organic carbon, iron, sulfur, and phosphorus. Minerals like vivianite and greigite within these spots suggest complex chemical processes that potentially link to microbes, but non-biological origins are possible. And then these minerals combination could have provided energy for ancient Martian microbes and a fingerprint for life. Researchers are still optimistic, calling the mineral composition combinations the best potential biosignatures. There were surprisingly big organic molecules that were discovered at Mars, and they lead us to the fact that there may have been life. So the Mars Curiosity rover discovered the largest organic molecules so far, and that was on March 24th, 2025. And here is a video of that.
Life on Earth is made from cells. Cells are surrounded by membranes, and cell membranes contain large organic molecules called fatty acids. Could these building blocks of life also exist on Mars? A new finding by NASA's Curiosity rover has scientists speculating. In 2013, Curiosity collected samples from a mudstone called Cumberland, leading to the discovery of small organic molecules like methane, chlorinated hydrocarbons, and thiophene. Now, for the first time, scientists have identified long-chain hydrocarbons within the Cumberland samples, the largest organic molecules yet discovered on Mars. Curiosity's onboard chemistry lab, called SAM for short, detected the hydrocarbons by using a new dual heating process that was developed after the rover landed. Scientists hypothesize that the long-chain hydrocarbons may be byproducts of fatty acids disintegrated during heating by SAM. If even longer hydrocarbon chains are present within the samples, SAM is not optimized to detect them. Instead, scientists hope to bring material from Mars to laboratories on Earth for more detailed analysis. 2,300 miles away from Curiosity, at the site of an ancient lake in Jezero Crater, NASA's Perseverance rover is already caching tantalizing samples for this purpose.
We discovered that there are ancient ice ages. There's new high-resolution imagery taken in January of this month that revealed groove textures and debris flows, confirming that Mars underwent recent ice ages caused by shifts in its orbital tilt. Then we have the Zebra Rock, where Perseverance discovered a black and white striped rock named Freya Castle in September of 2025, and it could be of volcanic origin, and they haven't seen anything like it before on Mars. Pure sulfur crystals in July 2025, Curiosity accidentally crushed a rock, revealing a field of bright yellow elemental sulfur crystals, a find that remains unexplained. And the meteorite Phipsaxla, which was a desk-sized iron nickel meteorite, was discovered by Perseverance in late 2025. So that helped us figure out things about the history of the solar system. As I mentioned, there's atmospheric electricity that was contained in the dust devils. Potential biosignatures were found in Chayava Falls in September of 2025. Perseverance analyzed the rock, and that featured lipid spots, and it's a chemical reaction fronts containing organic compounds, iron phosphate, vivianite, and iron sulfide, greatite. These signatures are consistent, according to scientists, with energy-generating chemical reactions used by microbial life on Earth. There's a massive underground reservoir. InSight lander data revealed a reservoir of liquid water trapped 7 to 13 miles down, and it contains enough water to cover the planet in an ocean of 1 mile deep. There are active water ripples and volcanic frost. In July of 2024, Perseverance discovered a rock on Mars that may have once hosted microbial life. The rock, nicknamed Chayava Falls, has chemical compositions and structures that could have been formed by ancient life. And on Earth, these types of features in rocks are often associated with fossils record of microbes living in the subsurface, according to an astrobiologist. And there are chemical signatures within that rock and structures that could have been formed by that microbial life. It's considered the most compelling potential biosignature found on Mars to date. It's an arrowhead-shaped mudstone measuring approximately 3.2 by 2 feet. It has those lipid spots that I mentioned before and contains organic compounds which were discovered by Perseverance's Sherlock instrument. The chemical lipid spot signatures are spots identified as concentric reaction fronts. I mentioned vivianite and greigite. And this is a picture of the rock. So when we finally get to live on Mars, this is just one potential habitat. We're going to have to grow our own vegetables. So Matt Damon, he had it right. And this is 2 weeks during Mars solar conjunction in November of 2023. It's 12 hours of Martian day. Moxie, an instrument on the rover, is capable of taking the Martian atmosphere and creating oxygen. So that's going to be very important for our astronauts. So if we have a Mars settlement, humans can become aliens. You have to remember that the gravity on Mars is 37.5% of Earth's. There's no protection against radiation and descendants. Well, first of all, we have Newton's third law. For every action, there's an equal and opposite reaction. So coming together could pose a problem. And how will young children develop away from Earth? And if the people on Mars are isolated from Earth, will they develop their own culture? And the answer to that is probably yes. They'll think about life here on Earth, going from continent to continent, different cultures. There are possible habitats for humans called skylights. These are lava tubes that can create cave openings and buried ice chunks that are located at the equator. So we can go in and create colonies within these lava tubes. And we know we can do that because we have lava tubes here on Earth. in Hawaii, for example. So here's an interesting theory. If you want to see a Martian, look in the mirror because of something called panspermia. Mars was battered by impacts and chunks flew off. And if there were microbes on Mars, they could have hitched a ride on those chunks that were blown off of Mars and came to Earth and then developed eventually into us. And that's known as panspermia. So the trip to Mars is going to be a long one right now. The round trip could take up to 21 months. 9 months to get there, 9 months to get back, and then 3 months to make sure Earth and Mars are in the right location for the trip home. We need to protect our astronauts from radiation, solar flares, coronal mass ejections, radiation that comes into our solar system from outside. We do have space weather reports so we can warn the astronauts, but keep in mind the delay in communications. We can build shelters to add more mass onto the spacecraft and onto the buildings that we're going to have on Mars. Lava tubes on the moon, as I mentioned. Water is a great defense against radiation. So other considerations, missions could last up to 3 years, and you'll have isolation and confinement. And different gravity levels as they go towards Mars. You start off on Earth, go to Moon, transit to Mars, and then you're actually on Mars. Spacecraft environments could be dangerous because microbes can change in the environment of space. What do you do with the trash when you're on Mars? We're going to pollute Mars too? Crew health. In early 2020, an astronaut on the International Space Station had a blood clot. But being 250 miles up, we were able to send up medicine to get rid of that blood clot, and the astronaut was fine. But within the last week or so, we had to return an ISS crew because of an astronaut illness. They didn't say who it was, they didn't say what the illness was, but it was serious enough to return the entire crew back to Earth. So now there's only 3 astronauts on the International Space Station. That's going to be difficult with going to Mars. How do you get medical supplies to them? You're going to have to make sure that they have enough medical supplies when they take off to Mars. And how do you get advice to them quickly in an emergency? Jumping can help astronauts with the trip to Mars. Cartilage damage is an issue. And according to research, jumping exercises can help protect astronauts from knee and hip pain, microgravity impacts nearly every aspect of the human body, thins out bones. Scientists worry that astronauts could also endure more long-term changes, such as damage to cartilage. Moon to Mars, we're going to return to the moon. We've got Artemis taking off in a few weeks, and we're going to be landing at the lunar South Pole. The reason being that there's ice in the lunar South Pole, which means there's water, and water is H2O. You can separate that. Hydrogen for fuel, oxygen for breathing. And we will eventually establish a permanent moon base. And there's less gravity on the moon, which means if we launch from the moon, it's going to take less energy to get to Mars. A big reason for getting to the moon is helium-3. It's a very efficient form of energy that can get us around the solar system, plus supply a vast amount of energy here on Earth. So if you're wondering why there's a space race to get to the moon, is a big part of the answer. We're going to use the Space Launch System. This is the crew that will be blasting off in a few weeks. And you can see the various launch windows. The Orion spacecraft can carry up to 6 crew members. But the interior has a habitable volume of about 316 to 330 cubic feet, which is roughly the size of a large SUV or 2 minivans. So imagine spending 9 months shut up in that. They better be friends. We're going to establish a lunar base. That's part of the planned Mars Artemis missions. It will serve as a stepping stone for Mars, for the Mars missions. And we can use the resources of the moon to extract that water, as I talked about before. We can use it as a proving ground for technology and for logistics and staging. The next steps are the lunar missions with Artemis. Mars launch windows happen every 26 months. Future Mars preparations involve lunar bases, and the moon is seen as the essential first step in learning how to live and work off Earth. And this is one of the technologies that will be used. They're looking at nuclear thermal propulsion, which could reduce the time to get to Mars by 25%. And this is the interesting thing that I found in Werner von Braun's 1953 book, Mars Project. He says that somebody by the name of Elon is going to get us to Mars. And thank you.
We've run a little over, but we have time for a couple of questions. Anybody have a question?
How strong are the winds? You know, you've seen The Martian, and they had to use the retro rockets to right the ship and that. And so I had read or heard something that it wasn't that strong. They're mild. They're just bulky with dust.
Yeah, they're not going to knock over rockets, but they are strong enough to spread the dust around the planet. So it'd be like I don't know how to equate it to what we have here on Earth, but very strong hurricanes here on Earth. Probably stronger than the strongest hurricanes we've had.
Oh, it is. Okay.
Yeah.
Right. Yeah. Something. Yeah.
What percentage of the ice is carbon dioxide ice or ice other than water ice?
That I don't know. I didn't get that deep into it. Sorry.
Okay, just a couple. Yes.
Great job. I have one question. How did Mars's molten core cool down?
Because Mars is so small, it couldn't heat up the molten core. So when it wasn't heated up, it stopped spinning. And when it stopped spinning, that means that the electromagnetic field that protects from the solar wind was no longer there. So the solar wind just stripped off the atmosphere. And if ours ever cooled off, we would suffer the same fate, but I don't think we have to worry about that.
All right, great presentation.
Thank you.
Question, with the heavy radiation at or near the surface, is it possible that the rover was not digging far enough to be able to find the people of previous life?
No, I don't think the radiation really affects it. And we feel that the depths that we're digging at are sufficient. For example, the tubes that I showed from Perseverance, we think those hold a lot of clues as to what may have been living on Mars, if anything was living on Mars. So we're confident that we're looking in the right places and at the right depths.
The veto of the Mars record, that was pretty recent.
That was last year. I'm going to take a guess and say probably mid-year. A lot of upset people. It's like, we've got these great samples. What are you going to do with them?
Any of our online guests, other than Ray Walston, have questions?
Well, Bill Bixby does.
Anyone? Okay, we'll repair to the observatory, and thank you very much, John. That was
Thank you.